So we've got our application deployed across our lifecycle environments, dev, test, etc. But how do we know what's installed into each environment? And more importantly, how do we track back what's in a given environment back to a commit in our source control repository? This is where we need some versioning being applied. And we can apply versioning to our API and also to our application independently. And we can combine those into a single release version so that we can identify which version of the application is actually in each environment. And one of the objectives here is to make this process as automated and as simple and seamless and transparent to our development team as possible, so that we don't burden them with anything additional other than creating the site. So let's go take a look at how we can make all this happen. Good morning, good afternoon, or good evening, whenever it is I find you, and welcome along to the channel. So we're talking about versioning today, and what do we mean in terms of versioning? What are we actually going to be looking at? So the versioning scheme that we're going to apply is a common one, and the default one that's used by Node.js is semantic versioning. So what do we mean? What is semantic versioning? So as you can see, semantic versioning basically consists of three parts to the version number. It consists of a major part, a minor part, and a patch. So the major part, which is the first part here, is when you make some breaking changes, you should increment that number. The minor part is when you add new features to your API or your package or application or release or whatever it is that you're versioning, but you're not necessarily making any breaking changes, so that's new functionality. And then the patch version number should increment when you're making bug fixes. There's also additional elements that you can tack on to the end of this that's detailed in this article here, that you can read at your leisure, basically to say whether or not you want some alpha or beta version, and indeed an increment that indicates maybe the build number or something like that. So we'll see how we can utilize some of those extra features to give us a bit more information than just the major, minor, and the patch versions. So let's dive in and see how we can use this. So I've got Visual Studio Code running, so let's just set up our environment a little bit so that we can see what we're doing. I've got the site running in npm. So here we are, up and running. So the first thing we need to go and do is let's go and version our API. Let's get that versioned. So if we go to our API folder, and if none of this is familiar to you, then you can follow along up to this point, some of the previous tutorials that are on this channel, so feel free to catch up to this point. But essentially what we can do is we can go into our API, our Azure Function API, and we can add in an extra tag into the CS proj file that details our assembly version. So as you can see, we're employing our semantic version and a build number. So for now, I'm just going to set that to all zeros. So that adds that into our API, so that actually when it's built, that's what will come out. But what we're going to do as well is add in an extra Azure function to actually return that version number to us. So we're going to come in here and I'm going to paste in some code. So we're going to create a version function which everyone can get access to. It's on a get method, and it's basically going to query the assembly that's running, so the executable that we've built for that version number. So when the executable gets built, it merges that assembly version into the built executable, and that's basically what we're asking for here. We're querying into the currently running executable, and we're getting that version number back out. and then we're just returning that as part of a JSON payload that comes back. So let's save that, come over and run up our API. And whilst that's building, we can come over here, and just to prove that that API is working, we can go into our API folder and call our new version function, and you can see that we are getting back 0.0.0.0, which is what's embedded inside of our executable. So that's good. So how do we then show this perhaps on our page? So let's close out that, because that's actually working. And what we can do is come over to our components and the footer, and perhaps we'll put some new elements down here that actually show us the version that's actually running. So we'll just add in to the footer, underneath that span that shows us the environment that's running, we'll do a break and a new variable called API version, which we're going to go and add now into the script. So a bit further down in the script, we'll get hold of the version. We'll create a new variable that we're going to populate with 0.0.0 hyphen, because it should be a hyphen if it's semantic versioning that we're following, and 0. So that's the default. But then what we're actually going to do is implement a fetch method. Right underneath that, we'll put a fetch method in, and the fetch method is going to use Axios get to call the version function. And we've gone through calling our API before in a previous video, so you can check that one out as well. And then we get back that version element out of the resulting JSON payload that we get back, and that's what we assign into the API version variable that we're then showing up on the HTML. This bit down here is basically converting that last dot that we get back from the API to hyphenate that instead, so that it finishes up in this style of format, which is correct semantic versioning, as opposed to the .NET style, which has a dot basically in between that last build number and the patch version. And we're only going to do that if the environment is either our dev or test environment. So we're not going to do that for prod, and that's because prod should not really have a build number. So prod should only have a version that's an actual official number of major, minor and patch. So we're going to not need to do that, because the build number shouldn't be there for the prod environment. So just to stop anything breaking down here in terms of what we're replacing here. So let's save that, and we can see instantly there that we get our API version has now popped up. So it's gone across, it's queried our API, got that version out, and that's what it's showing us down here. There's just one tiny little gotcha that I just want to point out for those that are following along. Previously we made all our Axios calls call the authenticate method. So this call here now, where it's going to get the version, is actually going to cause a call to the authenticate method as well. So just to show you what I mean, if I go on the network tab in the dev tools and refresh the page, you'll see that we've got a call to authenticate and a call to version. So let's just jump over here and say that if we're calling for the version, we don't actually have to authenticate either. So we'll let that rebuild, and we can now see that I don't get that call to authenticate, I just get the call to the actual version call. And that's only calling that once to populate the footer, so as I tab around I don't see any more calls to that version, even though we're actually still displaying it at the bottom of the screen. So that's nice, we only get that once. So that's just a little aside, just to clean things up a little bit there. So let's get rid of that. So that's nicely showing our development API version. So now we need to go and have a look at how we can show the application version. That is contained inside the package.json, and it's this version element here that we're going to show. And by default, Nuxt builds this and gives you a default of 1.0.0. So I'm going to change this to a valid semantic version with a build, so that we can actually see the build number as well. And then inside our Nuxt config, I'm going to come over here and import from the package JSON file. And then in our runtime properties, to expose version to the whole of our application, I'm going to create a new property called version, and that is going to be package.version. So that's now populating a version property from our package.json's version element. So back over, so I can save that rather, and then back over in the footer to actually see that. I'm going to add in another element to our footer. We're going to have that as app, and this time, because it's coming from that runtime properties and we don't have to do any manipulation of it, I can directly get it straight out of that runtime config. And we can see straight away there that our app version has now popped up and populated correctly from the version that's in our package.json. So that's that. And then the final thing that we actually want to go and add is the release version. So we are independently versioning our API and our application code components. So the way that we're going to do version is we'll add in a bespoke property called release into our package.json, and we will set that exactly the same as we set for the package.json. We save that, then we come back over to the Nuxt config, and then we can, because we've already done the import, we can just create a release variable and set that to package.release, and then come over to here in the footer and add in another element into our footer that shows us our release and release there. And that's not going to show up initially. I've got to stop and restart Nuxt to get that to be picked up. So let's just quickly do that. And once that rebuilds and reloads, we should see our release element pop up with our release version. So you don't necessarily have to show these versions on your website, but this is just to illustrate the point and show what's coming out and how each of these are being set independently for the purposes of this illustration. So that's useful for us to be able to understand what everything's been versioned at with our application. So with all of those changes done, we can commit those to the repository. But before we do that, I want to talk through the actual build job. So by default, in our GitHub workflows directory, we got this GitHub Actions build job that goes and builds our static site for us. So every time there's a push on main or there's a pull request, this job gets run. And what it does by default is it checks out your code and it runs this this build and deploy action down here, which basically tells it where the API lives and which is the distribution folder where the ending result build, and how to create that build so that it knows how to deploy that into the Azure Static Web Apps. So that's all you get by default. So I've gone ahead of time and changed this. So let's just talk through what I've actually changed here. So as part of the checkout action, you have to include the fetch depth of 0, and that's so that the Git repository, that when it gets created inside the GitHub Action virtual machine, it pulls down all the history with it as well. So that's so that the semantic versioning can query back through the Git history to correctly work out how many commits have been made and where they were made in the folder structure and all that kind of stuff. So that's all the information that the semantic versioning is going to look at to work out what the correct version is for a given component. So I've also added in the semantic versioning GitHub action that we're going to use, and all credit to Paul Hatch, who's created this one, and I'll explain why I'm using a different one as opposed to what most people use, which is the Git version GitHub action. But the reason why we're using Paul Hatch's one is basically because of this change path down here. So this particular GitHub action will actually look at specific commits and the folders that were impacted by that commit, and if you specify certain folders, then only if changes were made does it affect the semantic versioning. So if I was to make a change in the assets folder, then that commit would count towards the semantic versioning of this particular version of whatever it is I'm creating a semantic version for here. This does nothing except create an actual version, so it will create me a 1.0.0 and an increment. What it actually generates is based on this version format here, so I'm asking for the major, the minor, the patch, and then a hyphen, and then the increment or the build number, the number of commits that have been made since the last patch. So that could be in any of these folders basically. Yeah, it's going to walk back through the Git history to work out what that major minor patch is from the last label, and the last label that it's going to look for has to have this particular format. So it's going to look for a label of app v 1.0.0, for instance. It's anything after the app v. That's the actual Git tag that it's going to look for, and whatever the version is that's tagged with that, that's where it's going to start its versioning from, and then walk forwards in the Git history, working out what the semantic version is based on that. These patterns you can actually specify in a Git commit message that you intentionally want the minor pattern or the major pattern to move forwards a version. So if you've added new features, it's not just a patch. You can, along with your Git commit, say app plus semver feature or minor, and that will force this semantic versioning to advance by a minor increment. And you can do the same with the major one as well, but you specify breaking or major against the semver. So that enables developers to intentionally advance the commit, the versioning using just commits, nothing more than that. So that's quite useful. So anyway, this particular step is going to version our app component. So we're looking for a tag of app, and we set a version with a hyphen increment. If I come down, we then do a very similar thing, but for the API. So we look for a different tag in the Git history, one that starts with API version number, and we change our semver patterns to include API. So if you submit a commit of API plus semver, then it will advance the API versioning, and we slightly change the version format in terms of getting putting a dot in instead of a hyphen, because that's what the API csproj file, that's the format that it's expecting, not with the hyphen. And we also put the change path just to monitor the API folder, so only commits that affect the API will actually change this semantic version, and we'll do an example of that later. Once we've got those semantic versions generated, we can actually go through and add some steps. So we formally version the application, and we use the npm version command to do that, and we explicitly say that we don't want it to tag the Git repository with this version, because we're going to do that separately in a different manner, different way. But what we do is we ask it to version our particular package. So this is going to change that version element inside our package.json, and it's going to populate it with the output of the semantic version step above for the app. Yeah, and that's what that version property contains, is the 0.0.0 hyphen build number format is what's going to go there. So that's how we update the package.json before we do our build. We then do something similar for the API. We go through, we look at the API CS proj file, and we're basically replacing whatever is inside the assembly version tag with what we got from our API step, semantic versioning, just above. And we're using the Linux sed command to do that, and some regex expression there. So what we finish up at this point here, before we actually do our build and deploy, is we've updated our package.json here, and we've updated our API CS proj file here, so that then when we go ahead and do our build, those build numbers are actually built into what is generated and then hence deployed into Azure. So I've already checked this job in, but let's go back and commit all of these changes. Let's add a commit in there and push that up. If I come over to the repository and go to the actions, we'll see that there's a build job that's kicked off because we did a push into the main branch. So that takes a while to actually go and perform all that building and versioning, but we can hopefully step into it and have a look once it runs through these versioning steps, and we can see the versions that it actually generates. So it's still doing the pull at the moment. Just while that's doing that, let's come over and open up the actual site in Azure. So if we have a look at the various steps, so this is pulling out our code from the Git repository. We can then see the version of the app says it's at 0.0.1 build 16. So that's how many commits we've done. We haven't got any labeling, so it's all starting at version 0. For the API, I have actually got a commit that's got a minor. It's got one of these in it. So let me go and show you that, so that makes sense why that's the semantic version. So if I come over to the code and go and look at the commits, you can see here that I've got one where the comment is API plus semver minor. So I've indicated via that commit message that I want the minor version of the API to be advanced. So coming back over to the GitHub action, you can see then why the API is not at 0.0, but the minor version has been advanced from 0 to 1. So we're at 0.1.0 and build 3. So there's been 3 commits on the API since that semantic versioning advance. Hope that makes sense. So this is still building and deploying. It does take a while, but you can see here that our sed command is picking up that version from the semantic versioning job and attaching or applying that to the API CS proj. So that's now finished. So let's come over to our website and let's refresh that, and we can see that we are getting the versions being shown that are actually coming from our various different parts of the application. So the release hasn't been written to at all, so it's just pulling that straight from the package.json that we committed into the repository. So by default that's 0. The app has had the app semantic versioning applied, so it's at build 16 of version 0.0.1, and the API has also had its versioning applied. So that's okay. So let's go and have a look at how do we create a version, an actual release. So let's come back over here, and again, ahead of time, I've created a new GitHub action job in the GitHub workflows directory called create release. So let's open that up and see exactly what this is doing. So what we're doing is on a manual execution, so this doesn't run on a git push or anything like that. You basically have to go and manually trigger this job to run. So the developer would go and indicate that they want to create a release at this particular point, and that fires off this job. We're saying that we want to limit this job to only run if you're running it against the main branch. So if you've got some feature branches or release branches, this job won't run against those. You'll only run when you merge into the main branch. So the main branch is your source of truth for versioning. How you manage that in terms of Git flow or GitHub flow or whatever branching, merging strategy you're using, you usually finish up with a branch somewhere that contains the actual version tags. So in my case, it's on the main branch, but you can change this to as you see fit to fit with your particular Git strategy that you're employing. So again, we make sure that we're doing the fetch depth of 0 to pull all of that out, and we're using the semantic versioning again, but here we've got the addition of a semantic version for the release. So it's exactly the same approach. We look for a different tag, one with release and a version number after it to give us our base point for our semantic versioning. We can also advance the release using commits, whether it's a breaking release or just a release that's got new features in it. And the version format doesn't have the increment in this case. Because we're building a release, we don't expect or need the build numbers. We are going to set the numbers at the official major, minor and patch version. And the change path, we don't specify one. So we're saying everything in this Git repository will cause the release to be semantically versioned. Okay. The rest of it is the same pretty much as the regular build job that we've got. So this version's the app. We look for our app tag versioning. All of this is the same, other than the fact that we've dropped off, as I say, the increment there, because we don't want to version an actual release with build numbers. So all the folders that affect the semantic versioning for the app are all still the same. It's just we've dropped that increment number off in this particular job. And then we do the same for the API. Again, we've dropped the build number off the end of that, and we're only looking at the API. Then we do our actual versioning. So the bottom two ones are still exactly the same as they were in our build job, but we've added in one now to go and change that release tag in the package.json. We can't use the npm version command because our release is a custom tag, so npm knows nothing about that. We've got to use sed to actually go through and manually fix up that package.json with that release number, and we're pulling that release number out of the GitHub step that we generated the semantic version in. Once we've done that, we then go through and actually create tags in the repository. So if the release has actually changed, so if the semantic versioning step has determined that the release needs to be semantically versioned, then we run this particular step and we go through and we create a tag using the release version tag. So this will create us a tag that looks like release v 1.0.0, for example. And it tags that into the repository. And then we've just got a step here that shows us a nice version to say that it is actually going to add that tag into the Git repository. So we do that for the release. We also check the output of the app semantic versioning and see if that's changed and tag that accordingly as well. So we use the app down here. And likewise for the API as well, we check if the API has changed, and we go and tag that into the Git repository. We then go through and do an actual build. So because we've got a vanilla repository here that we've checked out, we have to do an npm install and then the npm run generate. We're doing these manually because we're not actually deploying this, we're just building the actual Nuxt application. So once that's built, we create a tar file, and into that tar file we put the dist folder that's created from our npm run generate, and we also put the API folder so that we can run our Azure function as well. And then lastly, we create a release, a GitHub release, which again, credit to whoever created this, but this takes the tag that we've tagged earlier. So that gives us, this identifies the commit that we actually want to build this release against, or create this release against. We give the release a name, so we give it the name of version and the number of the release, and then we also attach our tar file that we've just created. So what you should finish up with in your GitHub repository is a nicely tagged release with a version number against the actual commit that it's built against, and the Nuxt built API and final application, so that if you want to download those and run those somewhere else, you've actually got the finished built versions, not just the source code. So let's go and see if we can make that work. So let's come over to our repository, and we can see our create release job is there. So I can come over and run that job. And we see that that's now kicked that job off. So if we go and have a look at what that's actually doing, we can see that it's doing our checkout. It's semantically versioning the release, and it's versioning that at 0.0.1 because there's nothing else in the repository before that. And for the app, it's putting that at 0.0.1, which is what our last build said it was. And our API is at 0.1.0. So we've just dropped the build numbers off of those for the API and the app, and that's what we're actually building in. As you can see down here, we're tagging. So we've actually made some changes to all the components basically. So this, because this is the first time we've run this, we're adding a tag for the app at version 0.0.1. We're adding a tag for the API at 0.1.0. And we're adding a tag for the release at 0.0.1. And this is still going through and doing the Nuxt generate at this point. But I can come over to the actual code, and we can see those three tags have been generated. And if I come over to my Git tool and fetch the tags, then we can actually see that those tags have been pulled down, and those tags have been applied against the latest commit as we would expect. So that's nicely tagged up our API, or our repository rather, for all of our different components at the various different versions. So then the developers can start moving forwards again, making further commits, and that semantic versioning will take notice of those tags to semantically version the components going forwards. So let's just see if that has now finished that action. It has finished that action. So if I come over to the front of the main page of the GitHub repository, you can see we've now got a release in here at version 0.0.1 as we saw from the job. That's what it was going to create, and we've got our tar file that contains our build. So if we download that tar file just to prove that this is actually working, and then open that up, and then over here, if I get rid of those two and drop that in there, I can then go into the dist folder, the main page, and load that up, and we see that our release is at, just blow that up, our release is at 0.0.1, Our API isn't actually calling our API, so it's at the default, because remember that's an actual web service call to go and get that particular version, but the app has been correctly embedded at 0.0.1 as well, so that shows our versioning is actually working. So just to illustrate, as we roll forward with some changes, if I go to the API and just make some benign change in there that's not really going to affect anything, but if I do actually commit that in and push that up, we'll see again that over in the actions that's caused a build to kick off, which is what we would expect. The version has gone to the next version of the patch, as you'd expect, because there is a tag, an official tag. So if we go and look at our repository, because we've got an official tag here that says the API is at 0.1.0, the next commit advances the patch version because you're applying fixes to it, it assumes, unless you semantically version it with one of these semver commit messages. So if I just sync this repository up, what we can see is that the main branch has moved on and the API component has been changed, so that's moved on to 0.1.1, but the app is still at 0.0.1. So if we come back over to here, we can see that the app is at 0.0.1, build 0, and the API is at 0.1.1. So once this is finished building, we can actually go and kick off alongside that a job to create another version. Not that you do this every commit, but just to illustrate the point. So we're now going to version that. So just to show you how the tagging in the Git repository works, we had 3 tags, we've now got 5 tags. So we've got a new release version 0.0.2, and our API has got a newer tag against it. So this doesn't really represent it very visually in GitHub. So let's just go and quickly fetch those tags. Here we can see that our API and our release have been tagged against the latest one, but the app hasn't actually moved on semantically because it wasn't changed between the 2 versions. There was no commits in anything that should semantically mean that the app gets versioned, incremented at all. So that's working exactly as we would expect. We made a change to the API got versioned, and hence the release gets versioned because one of the components has changed. So hopefully you can see that the value in this, and that it's pretty easy and not too onerous for the developers. They can just create their commits, and as they create it, they know whether a commit is a breaking change or not, so they can semantically version the 2 parts of the application. If it's the API that's got a breaking change, they can do that, or if it's the Nuxt application itself that's got a breaking change. And then to create a release is just a single button click on this GitHub action over here. So that's it. Thanks for watching, and I will see you in the next video.